Hello everyone and welcome back to my channel. Today we are continuing our series on differentiation for the Math AASL course in the IB Diploma. Today we're talking about the quotient rule. If you remember last time we talked about the chain rule, which was how to differentiate two functions being multiplied together. If you haven't seen that video, go and watch it. It's an important concept that you'll need to know for your final exams. Today we're talking about the quotient rule, which is the differentiation of two functions being divided. In this case, let y is equal to 7x squared plus x cubed upon 3x to the power of 6. And we're asked to find the differentiation. So here's how we're going to do it. We're going to use the quotient rule. Now, what the quotient rule says is that for any function that can be represented as two separate functions being divided, as in this case y is equal to u by v, the differentiation of y with respect to x will be equal to the differentiation of the numerator with respect to x into the denominator minus the differentiation of the denominator with respect to x into the numerator, the whole thing upon the denominator squared. And this can be formally written as du by dx into v minus dv by dx into u upon v squared. Let's return to our original equation, 7x squared plus x cubed upon 3x to the power of 6. We're going to let u represent 7x squared plus x cubed and v represent 3 into x to the power of 6. Differentiate u with respect to x, so du by dx. So this will be equal to 14x plus 3x squared. And if you don't know how I arrived at this answer, please watch the video entitled Differentiation on my channel. It'll be in the description too. The next order of business is to differentiate v, which is 3 into x to the power of 6, and dv by dx will be equal to 18 times x to the power of 5. So here is everything that we need to find the differentiation of y with respect to x. We have the differentiation of the numerator with respect to x and the differentiation of the denominator. We have the original u function and the original v function. So let's go and put this into the quotient rule formula. So the first thing to do is to multiply the differentiation of the numerator into just the denominator, not differentiated, just the denominator. And then we're going to subtract this from the differentiation of the denominator into just the numerator, the original numerator undifferentiated, and we're going to square the denominator, okay? Please remember to square the denominator. It's an easy mistake to forget. Don't make that mistake and get more marks. So we can simplify these two expressions right here. So we're going to use the distribution of these, and we're going to get 42 into x to the power of 7 plus 9x to the power of 8, and we're going to do the same thing here. We're going to be distributing, and we're going to get 126x to the power of 7 plus 18x to the power of 8. And since we put the square sign on the denominator, we're going to get 9 times x to the power of 12. Remember that when putting some power to another power, the powers multiply. Again, a very simple mistake to just add them and continue on with the problem, but that is wrong. Don't make that mistake and earn more marks. So remove the brackets. So you'll notice that we distributed the minus sign. So we get 42x to the power of 7 plus 9 times x to the power of 8 minus 126x to the power of 7 minus 18x to the power of 8 upon 9 times x to the power of 12. Now here we have like terms because the variables have the same power. So 42 minus 126, we get minus 84. And since we have two variables of the same power here as well, 9 minus 18 gives you minus 9. So in the end, we get negative 84x to the power of 7 minus 9x to the power of 8 upon 9x to the power of 12. The differentiation of y with respect to x. Practice makes perfect. So here are some practice problems for you to do. Please differentiate the following using the quotient rule. Thank you for watching, and I'll see you next time.